From a dam, about 20 kiloliter of water is flowing at the beginning of an irrigation channel every minute. In summer, about 10% of the water evaporates from the irrigation channels in every kilometer. So these informations, so initial water flow at the channel from dam is 20 kiloliter per minute. So if we denote it by W naught, which is 20 kiloliter per minute, and the water evaporation rate, that is water reduces from the channel, that is this is a decay problem. So the water evaporation rate, so we can write it as decay rate of water, that is R, is 10% per kilometer. Now question A. What volume of water would flow per minute through the channel at 0.1 kilometer away from the dam? So this is the water flow rate at the beginning of the dam. In 1 kilometer, after 1 kilometer, 10% of the water will be evaporated. So water flow after 1 kilometer will be, initial water flow is W naught minus 10% will be evaporated. So 10% of initial rate W naught. So if we calculate it, you will get W naught minus 10% means 10 division 100 times W naught, which is 10 division 100 is 0.1. So it will be W naught. If we take the W naught common, then it will be 1 minus here 0.1. 1 minus 0.1. So we are getting 1 minus 0.1 means 0.9. So we are getting W naught times 0.9 kiloliter per minute. Now since W naught is 20 kiloliter, if we put that value, we will use this one later on. But if we put the initial flow 20 kiloliter per minute, then it will be 20 times 0.9, which is 18 kiloliter per minute. So the flow rate after 1 kilometer at the channel is 18 kiloliter per minute. Now question B. What volume of water would flow per minute through the channel at a point 2 kilometer away from the dam? So the water evaporates 10% per kilometer. So now question B, after 1 kilometer flow rate is this, in another flow rate is this, in another kilometer. So water flow after 2 kilometer will be, if we consider this one as W1, it will be W1 minus another 10% in next 1 kilometer of W1. So it will be W1, if we similar way, we will get W1.9, because here it was W naught minus 10% of W naught, we got W naught times 0.9. So here W1 minus 10% of W1, if we do the same similar calculation, we will get W1 times 0.9, and W1, that is water flow rate after 1 kilometer, is W naught initial flow rate times 0.9. So it will be W naught times 0.9, that is W naught times 0.9 square. So after 2 kilometer it is 0.9 square. So now we know W naught initial flow rate is 20 kiloliter per minute. So if we use that value, so we can write it as W2. We'll use this information. So now W naught is 20 times 0.9 square. If we calculate it, we will get this value as 16.2 kiloliter per minute. Question C. express the relationship between the water volume flow per minute through the channel with the distance in kilometer by an equation. So we can see W1 equals W0, that is initial flow, times 0.9 to the power 1. Similar way, after 2 kilometer, W2 is W0 times 0.9 to the power 2. So water flow, if we generalize it, water flow after x kilometer, if we denote it by Wx, it will be W0 times 0.9 to the power x kiloliter per minute. So this is the exponential equation that represents the water flow after x kilometer through the channel. Question C done. Question D. Use the equation and find the water volume flows per minute at a distance of 5 km. That means when the distance x is 5 km, when x is 5 km, x is 5 km, then the water flow Wx will be initial water flow W0 0.9 to the power 5, and this initial flow is, we know it is 20 kiloliter per minute. So if we put 20 here, so if we do this calculation using calculator, we will get 11.81 kiloliter per minute. Question E. Find how far the water will travel before 1/4 of it would evaporate. So initial quantity is W0, 1/4 will be evaporated. That means 1/4 of W0 will be evaporated. So then the flow rate, this is evaporated, this is gone. Now the flow rate after that distance, we will find that distance, will be initial flow rate minus the evaporation. So this will be the flow rate, which is 3 division 4 W0. So this will be the final flow rate at this distance. So if we use this general relation here, Wx, that is flow rate after x kilometer, is 3/4 of the initial flow rate, and Wx equation is equals W0 times 0.9 to the power x. So this is the flow rate after x kilometer, which is 3/4 of the initial flow rate. That means 1/4 is evaporated and 3/4 is still flowing. So the after x kilometer, the water flow is 3/4 of its initial flow. So now if we use this relation and W0 W0 will cancel, we will get 3/4 equals 0.9 to the power x. From here we need to find this x kilometer, x distance in kilometer. So if we take log 10 at both sides, log 10 3/4 equals log 10 0.10 base 0.9 to the power x, and we know for log this x power will come here as a multiplication. So from here we can find x equals this, x equals this division. If we bring these things in the left hand side, it will be division. So we'll get x equals log 3 division 4 division log 10 base 0.9. If we use calculator and calculate this part, we will get the value of x as 2.73 kilometers. So after 2.73 kilometers, 1/4 of the water will be evaporated.